In this video, we are going to be solving the problem on the board. Okay, here is the problem, and it says find I1, I2, I3 and the potential difference, which is PD, between B and C, that is between B and C. Now this problem is still a problem that can be solved using the Kirchhoff's law. In our previous videos, we've explained the Kirchhoff's law and we've as well solved a problem, and this is another one we're going to be attempting. Okay, now to solve this problem, as usual, we're going to create the equations, follow the steps, and then that will be it. Okay, it is that easy. First things first, remember the first thing we want to do most times is apply the first Kirchhoff's law, which is the KCL, that is the current law, or the junction law, okay, or junction rule. So you notice that there is I1 and then there is I2 and there is I3. How then do we get the relationship between these two using the current law? I1 is moving across this direction, going from here to here. That's what you notice. I1 is moving from here to here, right? And then when it gets to this junction, okay, it will get intersected by I2, which is also coming down. I2 is also coming down. So when I2 comes here, okay, it will look like they combine to flow in this direction to give it I3. Okay, we know that's because of the arrow sign that is given in the question. Okay, so I2, I1, they get to the junction, they combine, they flow downwards, which is I3, which means when you sum I1 and I2, you should get I3. Okay, so for the junction rule, it means I1 plus I2 is equal to I3. Okay, we can as well rewrite this to get I1 plus I2 minus I3 is equal to 0, and this is equation 1. Okay, this is equation 1. Now, the next equation that will be generated will be done by considering these two loops. So let's call this loop 1. Okay, go in the clockwise direction. Now let's call this loop 2. We're also going to go in the clockwise direction. Like I always say, you can choose to go in the counterclockwise, which is the anti-clockwise direction. You get the same thing. The only thing that will be different is the sign, and that sign will tell you that, oh, you're supposed to go in this direction. Okay, even by going the clockwise direction, I could get a negative sign, and the negative sign will tell me that, oh, I should have gone in the counterclockwise direction. So considering this first loop, okay, we are saying we are going to move in this direction, which should be the positive loop. Now I'm going to say considering loop 1. Okay, considering loop 1, if I start from this 10 voltage source, remember this line is longer than this one, which means here is positive, here is negative. And if we are going in this direction, what you notice that we are going from positive to negative. Positive to negative, what does that tell you? It tells you that we are having what now, a potential drop. That means the voltage here is what now, negative. So I'm going straight to the point. Now will be minus 10. Okay, come here, passing this I1. When you get here, you notice that, oh, what is the current flowing through I4? Most persons will make the mistake of saying the current flowing through I4 is I1 because it's coming here. No, you notice that when you're coming from I4, you get to a junction, which means it is not I1 that is flowing through I4 because of this junction. But when you choose to trace it back, you notice that, oh, I2 is coming from this direction. So when you trace it back, you notice that, okay, the current through what now? The 4 ohm is what now? I2, and the direction is in this direction, which means it is going like this. Okay, since it is going like this, it means the current is also what now? Moving like this for I4. And remember, current has to move from positive to negative across any element. So you have positive and negative, which means there's a potential drop here as well. So I'm going to write minus V4. Okay, to tell you that the potential drop across this place is negative and it's for the 4 ohm. That is why we have 4. Okay, when we continue, we meet another AMF again. Okay, here is the longer side positive, here has to be negative. So there is also a potential drop, which means we're having what now? Negative 14. So you have minus 14. Okay, if you continue, you notice that you get to I2 and then you get to another junction. Okay, and then the current through this 6 ohm resistor is not I2 because of this junction. Now when we trace it, you notice that, oh, there is a current along this line, which is what now? I1, which means the current across the 6 ohm is what now? I1. Remember, the current is going in this direction. That means here is positive, here is negative. But the direction we are taking is clockwise direction. So we are coming like this. We are coming from this point. And when we get to this point, we meet the negative first before the positive. So you notice after the negative, we get to the positive, which means there is a potential increase. Since we are not going from negative to positive to negative as the other ones, in this case, we are coming from negative to positive, which means there is an increased potential, difference, which means there will be positive, not negative, because we are going against current. Remember, Against current is what now? Increase the potential difference. Same direction as current, decrease the potential difference. Okay, so against current, that means we're having a what now? A positive voltage or a voltage rise for the 6 ohm, and that is equal to 0. We just apply the KVL, which is what now? The algebraic sum of the voltages in a loop is equal to 0. Here is the loop. Here is the algebraic sum. Okay, the algebraic sum simply means we are considering the direction, not just adding them directly. So from here we can simplify it to get minus 10. Okay, the current across the 4 ohm is I2, so I'm going to have minus I2, okay, times R4, okay, minus 14 plus the current across the 6 ohm is I1, so we have plus I1 times R6, and that's equal to what now? 0. So from here we can simplify. R4 is 4 ohm, R6 is 6 ohm, and minus 10 minus 14 is already minus 24. So we have minus 24 minus, I'm going to write the resistance first. Okay, minus 4I2 plus 6I2 equals 0. Now let's rearrange this to give us minus 4I2 plus, are we having I2 or I1? This is I2 and this is I1. Okay, so this is I1. Minus 4I2 plus 6I1 is equal to, taking minus 24 to the other side gives you what? 24. Okay, now we want to write the simultaneous equation. There is no I1, so we can write it as, oh, there is no I2 rather. So we can write I1 first. 6I1 minus 4I2 plus 0I3, because there is no I3, and this is equal to 24. Now this is our equation 2. Okay, so it is that easy. That is how we generate our second equation. Now we do know that we are generating three equations because the unknowns we are looking for, there are three: I1, I2, and I3. Okay, now to get the third equation, we're going to consider this loop. Okay, so we're going to consider loop 2. Loop 2. Okay, now for loop 2, we are still going in the clockwise direction. So where are we going to start from? We could start from anywhere. Okay, let's start from this voltage source here. Since we are going in the clockwise direction, we're moving from negative to positive. That means there is a potential increase of 10 volts. Okay, now when you get to this 6 ohm resistor, you notice that, oh, the current is going through here. So I'm moving from positive to negative. That is a potential drop. So in this case, we're having a negative potential drop, or rather a negative potential. So we have minus V6. Okay, what else is there? There is nothing else. When we get to this, we'll come back again. When we get to this one, okay, we'll notice that the current here is flowing in this direction. So that means here is positive, here is negative. And since that is also our direction, it means there is a potential drop. Same direction as current is always potential drop. So we have minus V2. What else is there? Nothing. And that's equal to what now? 0. So from here we have 10 minus the current across the 6 ohm is I1. So we have I1 times R6 minus current across the 2 ohm is I3. So we have I3 times R2, and that's equal to 0. So we have 10 minus 6I1 minus 2I3, and this is equal to 0. We can as well rearrange it, okay, just like the other one. So we're going to have minus 6I1 or plus 0I2, since there's no I2, minus 2I3, and that is equal to, taking this on to the other side, that gives you minus 10. Okay, equation 3. Okay, so we succeeded in generating the three equations. Next thing that we are going to do is solve simultaneously. So let's bring all the equations together. We're having the first one, I1 plus I2 minus I3 is equal to 0, equation 1. And then for equation 2, we have 6I1 minus 4I2, 6I1 minus 4I2 plus 0I3 plus 0I3 is equal to 24. Okay, that's our equation 2. Okay, and then for the third one, we have minus 6I1 plus 0I2 minus 2I3 is equal to minus 10. Okay, that's equation 3. So again, we're going to be solving this simultaneously using our calculator. we're having three unknowns. So we have 1, 1, minus 1, 0, 6, minus 4, 0, 24, minus 6, 0, minus 2, minus 10. Okay, take note that is minus 10. So that's going to give us an answer of I2, I1 rather, is 2 amperes, okay? And then I2 is minus 3 amperes. And then I4, I3 rather, is minus 1 amperes. Okay, now here is what the negative sign implies. Okay, for the first one, we're having I1 to be 2 ampere. When you come to the diagram, I1 is 2 ampere, which means the current across this loop is what now? 2 amps. Okay, now since I1 is positive, it means the direction of the current is correct. That is, this is the direction. Now for I2, the current is what now? Minus 3 amp. For I3, it's I2 rather, the current across this line like this is what now? 3 amps. But the direction is what now? Supposed to be in the opposite one. So that is what the negative sign tells us, which means in the question that was given to us, the direction of the current was assumed to be in this direction. But since we got negative, it means it's also be in the opposite direction. So if I'm to redraw the correct diagram, putting the current, it will be in what now? In this direction. And then for I3, we're having minus 1 ampere. It means the current across this loop is what now? 1 amp. Okay, but then the direction which was taken as this is wrong. It's supposed to be in this direction. Okay, so that is how a problem like this is being solved. Okay, but we are not done. We're also asked to find the potential difference between B and C. Now you come to the diagram, you notice that we're having point B and C are asked to find the net potential difference across this direction. Now since they said between B and C, not C and B, let's work in this direction. Okay, so if we are moving from here to here, we'll first of all encounter a potential difference, which is a potential increase minus to plus. Okay, that is what now? A 10 volts. Okay, so we're going to, okay, let's make use of this part. We're going to have a positive 10 volts, that is potential difference between B and C. Okay, we are going to encounter a 10 volts. Okay, and then a voltage across the 6 ohm, which is negative. We're going to have a potential drop, which is minus V6. Now this 10 minus, what is the current through this guy? It is I1 times 6, right? Okay, so from here we're going to finish it up. We have 10 minus what is I1? Well, this is for I1 gave us 2 amperes, so we're going to have 2 amperes times 6, and this is equal to 10 minus 12 amperes, 12 volts rather, right? So 10 minus 12, that will give us a value of minus 2 volts. So the potential difference across this guy is what now? 2 volts. Now the negative sign is only telling us that we are taking this direction. Okay, but if you are to take this direction, it will become what now? Positive. So it doesn't matter. What matters is that the magnitude of the potential difference between B and C is 2. It is only when we are dealing with current that the sign is going to matter. When we are dealing with voltage in our final answer, the sign does not really talk about anything. Okay, what it only tells us is that we are going from this direction to this direction, which we did. Okay, and going from this direction to this direction, we have a potential drop. And going from this direction to this direction, we are going to get a potential increase of what now? 2 volts. So the potential difference between B and C is simply what now? 2 volts. And that is how a problem like this is being done. Okay, if you did not get it completely, you might want to go over the videos again. Okay, and watch our other examples on Kirchhoff's rules. Okay, to get a better understanding. Okay, and if you did learn something, do what to like the video and share with your friends. Don't forget to click on the notification bell so that when new videos been uploaded, you'll be one of the first few persons that will get notified about it. Okay, see you in the next video. Bye.